Hey everyone, in this video we will discuss the question from CSIR NET 7 June 2023. This question is from complex analysis. So they have said that C is a okay, positively oriented circle in the complex plane of radius 3 circle, right? Positively oriented circle and it's of radius 3 whose center is at the point origin. That means the circle looks like this, whose center is origin and the radius is 3. Now they have said that what is the value of this integration. So this is a complex integration. It looks like integration fz dz, right? What is fz? 1 by z square into e to the power z minus e to the power minus z. So in complex integration, you know by Cauchy formula that if this integration fz dz, if fz has no residue, or if fz has no singularity inside this circle, then the value of this integration will be 0. But here clearly you can see that 0 is a singularity for this function fz equal to 1 by z square into e to the power z minus e to the power minus z, right? So we have to find the residue of this function fz at the point 0, because 0 is the only singularity. You can see z square have singularity and e to the power z minus e to the power minus z also have singularity at the point 0 only. Now we have to find the residue. We know what is the residue of a function. It is nothing but the coefficient of 1 by z, right? So we have to find the coefficient of 1 by z of this function 1 by z square into e to the power z minus e to the power minus z. Let's see how we will do this. So I can write e to the power z like this, 1 plus z square like this, summation z to the power n by n factorial, and e to the power minus z I can write this 1 minus z plus z square by factorial 2 plus so on. Now I can calculate this term like this. Even term will get cancelled by each other, and the odd term will be there. So there is z, there is minus or minus z, so there is 2z, and all the odd term will be in this form. So it is 2z minus 2z cube by 3 factorial plus 2z to the power 5 by 5 factorial minus so on. Okay, so from there you can take 2z common from both the terms, all the terms. Okay, so if you take 2z common, so it will become z square will become 2z cube, and this term will remain with 1 minus this z square by 3 factorial minus z to the power 4 by 5 factorial, right? Because 2z is common from there, 2z is common from there, 2z is common from there. So it will remain like this. Now I have written this for this term in this, right? I have taken minus common and take this term in this form. Why? Because if I write this term, suppose this is x, okay, this is a term x equal to this whole term, so this is of this form 1 by 1 minus x, right? And we know the well-known formula for this. What is that? This is 1 by 1 minus x is what? 1 plus x square plus so on, summation x to the power n, right? Or this is, I can write is 1 by 1 minus z is 1 minus this x whole inverse, right? So this is the formula to write this. Now we have to find the coefficient of 1 by z from this term, from this whole term. So this is 1 by 2 z cube, right? This is z cube. So wherever there will be z square in this big term, right? This looks complicated. So we will not find every term. We just need the coefficient of 1 by z. And there it is 1 by z cube. So we need only the term z square from this whole term. Then z square into this 1 by z cube will remain with 1 by z, right? So the z square term here is a z square term, right? So we can take this from this term. And is there any other term which is involving z square into some coefficient, some constant? No, there will be no other term. Here it is z square by, here is a z square, but there in the, it is a square term z square, but here it is whole square. So when you will expand this, the first term will be z to the power 4 into something, okay, and so on. There will be no other term other than this, which is only z square into a coefficient. So from there I will get the coefficient of 1 by z from this term only, that z square by 3 factorial, and this is 1 by 2 z cube. Okay, so it will be 1 by 2 into 3 factorial into 1 by z. Okay, but I need only the coefficient of 1 by z, so the coefficient of 1 by z is this 1 by 2 into 3 factorial. So I know now that the complex integration, how we compute the complex integration. Integration fz dz is 2 pi I into sum of the residue, right? Here the residue at the point 0 is 1 by 2 into 3 factorial, right? And so this integration value of this integration is 2 pi I into this residue at the point 0, which is 1 by 2 into 3 factorial. From there you will get pi I by 3 factorial, and 3 factorial means 6. You know, so this is the answer, right? Pi I by 6, 3. 3 is the right answer. The residue always you can find, suppose A is a, the point A is a singularity, then the residue will be given by the coefficient of 1 by z minus a. Okay, like this here, 0 is the singular point, so I have chosen the coefficient of 1 by z minus 0, that means 1 by z. Same, if there is any other question, then you can solve this types of question more preferable to ask in GATE exam. In the GATE exam, they ask this type of question, but this time in NET they have asked this. But this type of question is very important for GATE also. Okay, thank you.